Computer engineering is the combination of electrical engineering and computer science. As in, if you have the electrical engineering curriculum and the computer science curriculum, which don't share really any classes, the computer engineering curriculum is literally 50% of the EE classes and 50% of the CSC classes. Now this only accounts for your core major classes. It does not include the elective classes in your last years where you can choose from a long list of computer engineering, computer science, or electrical engineering classes to specialize in that I'll show you at the end. But let's dive into specifically what classes you take, which you already know if you've seen the computer science and electrical engineering videos. On the electrical engineering side, you'll have to take all their basic circuit classes, where you learn resistor, capacitor, and inductor circuits. You will solve for the voltage and current moving throughout them, and these are the simpler circuits, but are the techniques and components that are a foundation for circuits that exist everywhere, like in phones, computers, satellites, drones, etc. You will learn about the basics of binary and how computers make decisions using ones and zeros. This includes learning things like logic gates. These take in ones and zeros and produce a certain output based on the inputs. Each different gate does something different based on those inputs. Computers have hundreds of millions of those, and when strung together can do very advanced digital processing, such as for a digital lock, a wristwatch, an alarm system, etc. You also take one of their signal processing courses where you look at complicated signals or changing voltages in time and analyze them in detail. This is important in things like filter design and removing unwanted signals. Just like your radio in your car is being hit by every radio station in your city at once. So why do you only hear one at a time? Well, your electronics within process the signals and filter or remove everything except the one you're listening to. So when you tune to, let's say, 94.5 FM, your car is allowing signals of 94.5 megahertz to pass to your speaker, but filtering out everything else so you only hear that station. So you analyze the math behind the manipulation of these signals and see how to determine which frequencies they are made up of. This is essentially a math class and involves a good amount of calculus. If high-level math and this class seem interesting, then electrical engineering may be better for you. Although computer engineers do have to take multiple years of calculus and apply it in some other of the electrical engineering classes as well, so hopefully you enjoy math somewhat before entering this major. Then lastly, you'll take half of their electronics courses. This is where you look at the transistor and diode. A transistor has the ability to switch between a high and low voltage, like 5 and 0 volts, and computers read these as ones and zeros. So that's what we actually mean when we say a computer reads ones and zeros. There are over 1 billion transistors in your laptop to make it work and store all the data. So you'll do circuit analysis, but now with the knowledge of how transistors work, which are way different than a simple resistor, but apply the same principles like looking at voltage in a loop and conservation of current you may have seen in high school physics. In the lab, you'll hook up circuits on a breadboard. These are where circuits go for basic testing, then once everything seems to work, that's when you would move it to a circuit board that you've probably seen in computers and phones. How you test them is by using an oscilloscope, which is where you literally see the electric signal or changing voltage in time. So you'll see maybe if the voltage in a transistor is changing between a high and low one, or as a computer would see them, a 1 or a 0. This is all the hardware, the electronics, the circuits, the breadboard, etc. that computer engineers need to learn. But now let's get into the software or the computer science side. You'll start to learn the basics of programming in C and Java. C and Java are programming languages that have their own syntax and rules you have to follow that tell the computer what to do. These are the languages that Google, Facebook, LinkedIn, etc. all use to make their websites work. These are not the languages to make the layout of the page or to make it look pretty. That's HTML and CSS. These programming languages are the backbone of the websites. Like, how does Google search their database and bring up the results quickly, efficiently, and with the best results first to help you find what you're looking for? Or how can Pandora guess songs you'll like based on what you've listened to or rated, and so on? These are what programming languages accomplish. Programming is what makes apps, video games, and even instructs things like unmanned aircrafts and satellites. But you'll start from the very beginning if you've never coded before. So in your first class, you might be asked to write a program where a user can type in 2 numbers and it outputs the sum. Or they input a list of numbers and it outputs the largest. Or they input a word and it outputs that word backwards. By the end of it, you may be asked to program something like a very basic blackjack game. You'll also get into some basic algorithms, which are kind of like step-by-step instructions to solve a problem, just like this image even. But in programming, you'll be asked things like, how do you tell the computer to put a list of numbers in order as efficiently as possible? Or how does the computer search if a number is in a list? So you gotta understand what the computer can do. This may be easy for us to do using our brain, but computers are not free thinking. They need exact step-by-step instruction to do what you need them to. As a quick example, if you had a list of numbers in order and the computer had to check if the number 26 is there, well, you could tell the computer start with the left, check each one until you find 26 or run out of numbers, which is probably what you did in your head very fast just now, but that takes 9 checks. So what if instead we have our list and we took the middle number and 26 is bigger, so we threw out everything else less than or equal to that middle number. Then with the new list we did the same thing. Check the middle number and look, we already find 26. And even if it weren't in the middle in this check, this is still way often less steps than the previous, and therefore it's more efficient than checking each one by one. This is one kind of searching algorithm and is the kind of thinking you'll need for programming. Programming mostly doesn't involve high-level math. You won't see calculus in basically any undergrad computer science classes, but you do need to problem solve and have the ability to analyze these using simple math, but in a clever way that the computer can understand and follow. And note, I just showed you how the algorithm worked. In the class, you'd also have to program it using knowledge of the languages. Lastly, one of students' favorite classes is where you learn about the Arduino. This is finally where hardware and circuitry meets programming, and you'll take with electrical engineers. The Arduino has lots of inputs for you to hook up wires from an external circuit. As in they basically read in voltages, then you program what you want it to do based on those inputs, where you plug in and download the code onto the Arduino, then use it for different purposes. So maybe you use a position sensor connected to a circuit and then connect that to the Arduino. The Arduino reads in voltages, which may be higher or lower depending on if an object is close or far, then program the Arduino to output voltages, which it can do as well, when an object is close, that spin the wheels of a robotic vehicle to avoid that obstacle, and thus you have collision avoidance. Overall, computer engineering is great because you have skill on the programming and software side as well as the hardware and circuitry side. So if you wanted a job at maybe Apple, you could work on their software, operating system, or iOS, the system memory, the servers, or with their encryption and security. Or you can help with their electronics and hardware. You can work at defense companies on something like obstacle avoidance for UAVs, or create a computer simulation for an aircraft and radar system to see how it will work in theory before designing it. Probably hard to get that kind of job right out of school, but you can see how your future career has a lot of potential. On top of being a mix of electrical engineering and computer science, you will take electives where you can choose from any of the upper division computer engineering, electrical engineering, or computer science classes. Some may include computer security and learning about firewalls and access control, computer vision and looking at image processing of 2D and 3D images on the computer like facial recognition software, autonomous robot navigation and programming vehicles to move around automatically, web development and interactive website design, and of course, so much more.